Good day, guys. Today we're doing question 2, and question 2 starts with, given the quadratic sequence 2, 3, 10, 23, write down the next term of the sequence. So with quadratic sequence, we know that the second difference, we're working with the second difference being constant, and the question asks for the next term of the sequence. Now let's look at our first differences. That's 1, the difference here is 7, difference here is 13, and let's check our second difference, be 6 and 6. So if I want another 6, 13 will give me 19, and 23 plus 19 should give me 42. So my next difference is therefore G5 equals to 42. They then ask us to determine the nth term of the sequence, and we know our general form to be an squared plus bn plus c. Now remember, guys, it can be confusing. You may think this a is the first term, but it is not. Don't confuse yourself with that. We basically have to find values for a, b, and c. And if you don't know how to do that, well, if you don't understand the formulas, please ask and I'll do a video that shows how. But we know that our second difference, which is 6, is equal to 2a. So we can solve for a. 6 over 2, we divide both sides by 2, gives me 3 and a. So I have an a value, and then I know my first difference, the first term of my first difference is 3a plus b equals to 1. So I can use that. 3a plus b equals to 1, and I can solve for b if I substitute the a there. I'll take my 9 to the other side, and b is equal to minus 8. And lastly, the formula for my first term is a plus b plus c is equal to, for term 1, so I have a as 3 plus minus 8 plus c is equal to, and my absolute first term, term 1, is 2, and I solve for c, which gives me 3 minus 8 plus c equals 2, and now that I have a value for a, b, and c, I can substitute it in. Minus 8 n plus, and that would be my general term, my nth term. I mean the formula for the nth term. If you're confused about how I got that and that and that, please message me and let me know. I'll do a special video just for you Okay, the next one asks us to calculate the 20th term of the sequence, and that's quite straightforward. Once we have our formula, we can substitute 20 into each one. Let's do that. If we said t of 20, means wherever there's an n, we put in 20. 3 into 20 squared minus 8 times 20 plus 7. You could put that into your calculator. Where's mine? Well, you should get 1047. And that's your answer. Okay, we then have calculate, given the arithmetic sequence 35, 28, 21, calculate which term of the sequence will have a value of minus 140. When dealing with arithmetic sequences, we use the formula Tn is equal to a plus n minus 1 times d. And this is in your formula sheet, so you don't need to know it, but you ought to be able to identify which formula you use for the arithmetic sequence. And we're looking for, they've given us Tn equals to minus 140, and they want us to find n. We know that a is our first term, 35, and d is our common difference, and the common difference should be, what is it, minus 7. Basic, we substitute a is 35 and our difference is minus 7. What do we do? Let's multiply minus 7n plus 7. Let's get my like terms together. I'm going to have 0 equals to 35 minus 7n plus 7 plus 140. Gonna take minus 7 to the other side, it becomes 7n. And if I add these, 35 plus 40, should get 182. Okay, and divide both sides by 7. N is equal to 26. That means we are looking at the 26th term is equal to minus 140. And then we have question 2.3, which asks, for which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in 2.1? What are they asking? Oh my god. Okay, let's understand first what they're asking. There's two parts to this. For which values of n? So we're looking for n. We're going to be, where's my paper? Let's just write down the information we have, right? Okay. Which values of n? So we know we're going to be searching for an n. Okay. Well, the sum of the sum of, okay, they're looking for sum of. So do we know our sum of formula? Again, it's in my formula sheet. For arithmetic sequence, that's its sum of formula. Okay, I'm gonna write it down. Okay, that's my sum of formula. of the arithmetic sequence be equal to the nth term of the quadratic sequence. Now remember, they asked me to determine the nth term, and I've got that. That was my nth term, so I'm going to write it down. So what they're asking is, when this is equal to this, what is the value of n? Let me set up my equation, okay? N over 2 into 2a plus n minus 1 times d. When it is equal to 3n squared, solve for n. One more time, they ask the sum of the arithmetic sequence, and that's that, the sum of the arithmetic sequence equal to the nth term of the quadratic sequence. And that is the nth term of the quadratic sequence. That is what they're asking you. It may be confusing, but just understand the question. Try to figure it out. Okay, let's simplify to solve for n. Need to substitute first. N over 2 into 2 times 35. Alright, it's smaller than the natural. Okay, first I'm going to take this 2 all the way to my other side. So I have n into, let's multiply that, 70 plus, let's multiply that, well, minus 7n plus 7 equals to 2 multiplied by 3n squared minus 8n plus 7. Let's multiply this n into there, into there. I have 70n minus 7n squared plus 7n equals to 6n squared minus 16n plus 14. I'm going to move everything to the other side. If I have 6n squared, if I take this to the other side, it's going to become positive. So I have what would I have? 13 n squared minus 16n. Do I have any? No. Plus there. It's gonna become plus 14. Trinomial, set that up. I'm going to use the quadratic formula. And of course, you know that this cannot be applicable because not applicable because it needs to be a whole number. So that is your correct answer. By the way, if you factorized, you would have gotten 13n minus 2.